How does AI recognize handwritten numbers? To humans, this is obviously the number 3, but a computer does not actually see numbers or shapes. It only sees numerical data. Every pixel has an intensity value. Bright pixels become large numbers, dark pixels become smaller numbers. So images are converted into matrices of numbers. The numbers enter the neural network through the input layer. Each neuron receives one numerical input. At this stage, the network still does not understand the image. Each connection has a weight. Weights determine which inputs are more important. The neuron combines all inputs into a weighted sum. The bias term allows the neuron to shift its output. The activation function decides how strongly a neuron should activate. Without activation functions, neural networks would only learn simple linear patterns. Activation functions allow neural networks to learn complex relationships. Hidden layers gradually build more complex understanding. Early layers may detect simple edges or curves. Deeper layers combine those features into meaningful patterns. This is how neural networks slowly learn to recognize objects. But how does the network actually learn? To understand that, we need to talk about training and backpropagation. After information flows through the network, the final layer produces predictions. Each output neuron represents a possible answer. The neuron with the strongest activation becomes the final prediction. Sometimes the neural network makes mistakes. The network must measure how wrong the prediction was. This is called the loss function. A larger loss means the prediction was far from the correct answer. Now the network must figure out which connections caused the mistake. The error signal travels backward through the network. Each connection receives feedback about how much it contributed to the error. This process is called backpropagation. The weights are adjusted to reduce the loss. Tiny improvements happen after every training step. Over time, the network slowly moves towards better predictions. As training continues, the loss gradually decreases. The network becomes more accurate over time. The same ideas now power some of the most advanced AI systems in the world. From image generation to large language models, neural networks are everywhere. Neural networks learn by improving predictions, and that simple idea became the foundation of modern artificial intelligence.